Today we're going to talk about page 9 of your section 5.8, 5.9 notes packet. We're going to talk about solutions of systems of equations. And tomorrow we'll talk about the inequalities. Well, first of all, what is a system? A system of equations is a set of two. Well, we'll talk about only two. You could have more equations, but we'll just talk about two equations. A system that we're going to talk about will have a quadratic equation, and the graph is going to be a parabola. And then it's going to have a linear equation whose graph is a straight line. And that's called a quadratic linear system in two variables, and those two variables will be x and y. In the set of real numbers, a system may have two solutions, one solution, or no solutions. And each solution is going to be written as the coordinates of the points of intersection of the graph of the parabola and the graph of the line. So if you look at this picture, we have a quadratic equation that has been graphed as a parabola. We have a linear equation that's been graphed as a straight line, and the solution is where they intersect. So we would just darken the two areas where they intersect, and that has two solutions, those 2 points. This parabola intersects this line only at one point right there. It just brushes the side of it. And so this one has only one solution. And sometimes parabolas and lines never intersect. These will go up forever, and this just slants off forever. And this will have no solutions because they don't intersect. So we have one of these three situations that we have to figure out. And when we figure out where they cross over each other, we're just going to figure out the x and the y values of where they cross, and that will be the solution, the x and the y. So what we're going to do is solve it graphically first, and then we're going to solve it algebraically. Well, graphically, you're going to calculate the points of intersection by putting it into y1 and y2 into the calculator. And then if you want to solve it algebraically, we're going to isolate one variable, usually it's y, in one equation, and then substitute into the other equation and solve. I want you to add this: solve for both x and y, because we have x and y coming out of this, so you need to solve for both. Some people stop after they figure out what x is and think they're done, but you're not done until you found out what y is. So here we go. We have a system. This is a linear because it's not x squared. This is a quadratic because it's x squared. So we're going to first solve it graphically. And this is y is equal to x plus 2. Even though the y is on the wrong side, that's okay. What we can do is take it into our graphing calculator. Y is equal to x plus 2. And then y is equal to, put that in y1. And in y2, we'll put negative x squared minus 3x plus 7. So please have your graphing calculator and go along with me when I'm going through this, so you can see what's going on here. And then if you press the graph button, there's the line, the linear graph, and there is the quadratic graph. And those 2 points of intersection will be the solutions. So what we're going to do is just kind of do a rough sketch of this. We can look at the table of values if we want, but since we're given this just a general XY axis, let's just sketch this to the best of our ability, freehand. This parabola is going to come down like this, and then the line goes up like this. And we're going to label these. Y equals x plus 2, and the other one, this parabola, is y equals negative x squared, what was the rest of it, minus 3x plus 7. So we have two graphs, and then these 2 points of intersection are the solutions. So let's darken the spots where they cross over each other. And to figure out where they cross, it's just like what we did before. You're going to do second calculate. We're going to calculate their intersections, option 5, and then move the cursor close to the first point and hit enter 3 times. X is 1 and y is 3. When it says intersection, that is the solution, 1, 3. So label that as 1, 3. And then we're going to find the other point by doing second calc, option 5, intersect. And now we have to move the cursor down closer to this point of intersection and hit enter 3 times. And then it'll tell us our second intersection is negative 5, -3. So there's our other solution. It's pretty fast when you do it graphically. So those are the solutions. And put them together in XY pairs, -5, -3, and 1, 3. Okay, those are the solutions to that system. Algebraically, it takes a lot longer, but what you're going to do is, it says isolate one variable. So this is already isolated, that x plus 2 is equal to y. So what we're going to do is we're going to substitute into this quadratic. We're going to take the y out of it and put x plus 2 in its place. So it's going to read x plus 2 instead of y equals -x squared minus 3x plus 7. That is substituting for y, right? Well, since this is a quadratic equation, you have to solve it by setting it equal to 0. So you have to subtract x and subtract 2 from each side. So you're going to get a 0 on this side, and is equal to -x squared minus 4x plus 7 minus 2 is 5. Well, I don't like this -x squared. When I factor something, I want it to be positive. So we're going to divide both sides by -1, both sides, which 0 divided by -1 is still 0. And then all of these get divided by -1. It just means you're going to change all of the signs, x squared plus 4x minus 5. So now we're ready to factor this. The factors of -5 that add up to +4 are what? +5 times -1. So x is equal to -5 here, x is equal to +1 here. And now we're going to set up a table, because once we figure out what x is, we have to now find y, because you're not done when you find x like usual. So, whoops, now, if I can write, now find y. Okay, and so just set your table up here, because when x is -5, y is going to be something. When x is 1, y is going to be something else. So from the original equation, y is equal to x plus 2. You can choose either one, but that's the easier one. So since y is equal to x plus 2, that's from the original. All you have to do is substitute -5 in for x. -5 plus 2 is equal to -3. So when x equals -5, y equals -3. So -5, -3 is the solution. It's the same one that we got graphically. Now when x is equal to 1, you're going to use that same y equals x plus 2 equation from the original and substitute a 1 in. Y equals 1 plus 2, which is 3. So when x equals 1, y equals 3. So 1, 3 would be your other solutions. And that's done algebraically. So we got 2 solutions here because there were 2 points of intersection. Next page. These are similar problems, just the examples are just a little bit different. So let's do this graphically first. So plug in y equals 3x squared minus 2x plus 4 into y1. And on this second one, you have to solve this for y. You have to subtract x from each side, so y equals 6 minus x, or -x plus 6. I'll do 6 minus x. Same thing. All right, so let's take a look at this one. All right, we have 2 points of intersection, one in quadrant 2 and the other in quadrant 1. So let's just graph this up here. And let's find the points. Second calc, intersect, enter, enter, enter. The first one is x equals -2/3. 0.66667 is 2/3, and y equals 6 2/3. So I'll write this. Let's see, I'll write this as -6 repeating, 0.6 repeating, and then y is equal to 6.6 positive repeating. So there's one solution. Make sure you put the repeating bar over the top, or else it's going to be wrong. Now you're going to do second calc, intersect, and get the other one. And x equals 1 and y equals 5. So 1, 5 is the other solution. So this one has 2 solutions. So since y equals 6 minus x, you're going to take that and you're going to substitute. S-U-B-S-T means substitute. So substitute a 6 minus x in for that y. So it's going to be 6 minus x equals the whole thing, 3x squared minus 2x plus 4. Now you have to subtract 6 and add x to both sides to get a 0 over here. So subtract 6 and add x to both sides. So we have 0 is equal to 3x squared, negative 2 plus 1 is negative 1x, 4 minus 6 is negative 2. Well, this is factor in, factor out, so the factors of negative 6 that add up to negative 1, what are they? Minus 3 plus 2. So factor in, factor out says I have 3x minus 3, 3x plus 2 from those, and divide the whole thing out by 3. So this is the one that's going to be reduced down. So this says x minus 1 times 3x plus 2 equals 0. Well, what does this x equal? This x equals 1. Put it in a table. And what does this x equal? If you subtract 2 from, if set this equal to 0, subtract 2, divide by 3. X equals negative 2/3. And now we have to solve for y. Way back up here we said y equals 6 minus x. So we'll use that, y equals 6 minus x. Well, x is negative 1, so 6 minus 1 is 5. So this solution would be x equals 1, y equals 5 as a set of ordered pairs, just like it was over here graphically. And then over here, when x equals 2/3, y equals 6 minus x, y equals 6 minus a negative 2/3. And 6 minus 2/3 is plus a positive, so that's 6 and 2/3, which is equal to 6 and 0.6 repeating. This negative 2/3 is also equal to negative 0.6 repeating. So you can put those in decimal form if you want, or if you want to leave them as a mixed number, it doesn't really matter, right? But that's negative. And this is positive. So negative 0.6 repeating, comma 6.6 repeating would be the two solutions to this problem. Next one, y is equal to negative x minus 3. And we have to throw the 3 over on the other side because we have to isolate y. So we're going to turn this into y is equal to x squared minus x minus 3. And then y equals negative x minus 3. Let's see what that gives us in our calculator. X squared minus x minus 3. Oops, I forgot my x. Oh dear, start over. X squared minus x minus 3, and then y equals negative x minus 3. Take a look at that one. Oh, it looks like this brushes it off, brushes over the parabola just once. So second calc intersect. It looks like the intersection is at 0, negative 3. That's right on the y-axis. So we'll go down to 0, negative 3 right here. And the line went like this. Oh, I forgot to label these two up here. This one is y equals 3x squared minus 2x plus 4. And this equation is y equals 6 minus x. This equation is y equals negative x minus 3. And then this parabola that just brushes over that line in just one spot is y equals x squared minus x minus 3. So it looks like that point of intersection is at 0, negative 3 solution. Okay, let's do this algebraically. So we're going to do a substitution again. We're going to substitute negative x minus 3 in for this y right here. So get that y out of there. And we're going to say negative x minus 3 is equal to x squared minus x minus 3. Substitute. Add x and add 3 to both sides. You're going to get a 0 over here. And then you have x squared 0 equals x squared because negative x plus x is nothing. Negative 3 plus 3 is nothing, so 0 equals x squared. Well, if you take the square root of 0, you're still going to get 0, so 0 equals x. There's only one solution. So now we have to solve for y, and up here we said y is equal to what? Negative x minus 3. So you substitute x equals 0, so y equals 0 minus 3, so y equals negative 3. So the only solution you have is 0, comma negative 3. It's one solution. And our check is the graphic check. And let's just do one more over here. Let's see, what do we have to do? We have to get y by itself. Well, I don't like a negative y, so I'm going to add y to both sides. I'm going to put y on this side and call it positive y. I'm going to add y. And then I'm going to take the 3x and subtract it. I'm going to take the 2 and add it. So this is going to be y is equal to positive x squared, a negative 3x, and a positive 2. If I just switch the sides, remember, just switch the signs. And this one, I have to take this 4x and move it to the other side, so I'm going to subtract 4x. So y equals negative 4x minus 1. All right, let's see what that looks like in our calculator. Y equals, clear that stuff out, x squared minus 3x plus 2, and then the other one is negative 4x minus 1. Let's see what that looks like. Oh, it looks like this line doesn't touch this parabola at all. I'm going to just make sure. I'm going to change my window. So if I press my window button, if I want to see higher up, I have to change my Y max. I'm going to change my Y max to like 40 to get up kind of high on this graph. Let's take a look at it with a new window. So there's my parabola. Here comes my line. Yep, it looks like there's a gap in there, so there's going to be no solution to this because this line gets further and further away from this parabola. So we can graph that. I'm going to just zoom 6, which takes us back to the standard window. It looks like it goes underneath the x-axis a tiny bit there. All right, negative 4x minus 1 is steep. I should probably draw nice straight lines to help. So y equals negative 4x minus 1, and then this parabola comes down and just goes underneath the x-axis a little bit and comes up like this. Y equals x squared minus 3x plus 2. And so you can say there's no solution because the graphs do not intersect. So if there's no solution graphically, you can figure that out algebraically also by doing the same thing. We're going to substitute this negative 4x minus 1 in for this y, or we could substitute this x squared minus 3x plus 2 in for this y. I think I'll do it that way. I'll take this x squared minus 3x plus 2 and substitute it in for that y, so I'm going to make it equal to negative 4x minus 1. Let's see what no solutions look like algebraically. So you're going to add 4x and 1 to both sides, and you're going to get x squared plus x plus 3 equals 0. This is unfactorable. There are no factors of 3 that add up to 1, so you'd have to use x equals negative b plus or minus the square root of b squared minus 4 times 1 times 3 is 12 all over 2a, right, for the quadratic formula since it's unfactorable. So this is equal to negative 1 plus or minus the square root of negative 11 over 2. That is imaginary. All right, imaginary x values means there is no real solution. Imaginary results, and it means the graphs do not intersect. So that's it for today. We'll see you tomorrow.